are back, and we'll keep exploring the robotic revolution. So I'm now calling on stage Mr. Thomas Engel, please. And Vincent Tardieu, please, yes? I'm waiting for you on stage. We'll begin with you, Mr. Thomas Engel. You're John Deere's Manager of Technologies Innovation Strategy, and you'll make us look back from self-steering tractors towards autonomous field robots, if I'm correct.
Thank you, and thank you for the invitation. I'm glad to come and talk a little bit about our perspectives on autonomous vehicles and field robots. I have now the challenge to keep you awake after lunch. I hope that will be not too difficult, and I hope my talk will be exciting enough. So what can you expect? I think I will first talk quickly a little bit about John Deere, so that everybody knows who we are, then talk shortly about automatic steering solutions and the success we had there, then talk about autonomous vehicles more in general. So what are drivers, what are challenges, which applications do we see in the market, and also some words around swarm technologies and the role of electrification. And finally, a short outlook and summary. So here's just some numbers from 2017. You see here our headquarters in Illinois, and we had last year around 60,000 employees. Now we are already above 70,000 because we made a major acquisition, but not in the agricultural space, in the construction space, where we added another 8,000 employees. Total revenues, and that's also not so important. What I want to show you is what are the areas we are in, and agricultural equipment is clearly our major area where 2/3 of our sales come from. But then you see also construction is getting more and more important. We have on the right-hand side on the top, I'm not sure how this works. Oh, I don't know. Oh yeah. So here you see, for example, a loader which is not sold in Europe, but here you see that latest acquisition, Wirtgen, who have a lot of equipment around road construction. So this is something, that was wrong. So this is also a growing area. Turf equipment is important, forestry. We are also in forestry equipment, the #1 worldwide, and these are very complex machines. But overall, the revenue is much smaller. And what is also important in the middle, and that's why in the middle you see that tablet computer, I think intelligent solutions, our intelligent solutions group, which works on all these high-tech areas, is getting more and more important and is growing in the company. So what have we done towards automatic steering solutions? Already in the late 90s, I think we were convinced that at that time GPS is important for a successful future farming. That's why we acquired Navcom Technologies, and then we developed our own receiver and our own correction data network at that time to be able to steer the machines or to locate the machines first. With now in the meantime, I think with the correction data, we come to 3 to 4 centimeters accuracy with that correction data network. But we started with GPS and GLONASS, but we had challenges first with GPS only, that we didn't see enough satellites. So in corner conditions, trees, etc., you couldn't really use the system. Then we added GLONASS, that helped already a lot. And now we are just in the process of Galileo and adding Galileo and Beidou. We have already software running. It again improves accuracy to below 2 centimeters, but that's not so much more important. The more important thing is it's really now really stable. Nearly everywhere you can use the system, even if you have trees and on both sides, you can still run the automatic steering system.
It is not a holdup.
Okay, so I think I stopped here saying that the these multi-constellation GNSS receivers, they are now so reliable and work nearly under every conditions, corner conditions with trees, etc., that these systems have been used for automatic steering systems, which are very successful. You see here these pictures, they are already at least 10 years old. We introduced automatic, at that time, GPS-based steering systems 2003, so exactly 15 years ago. And in the meantime, we have added functionality, so you can really run these tractors in the field without touching anything in the whole field. So the system would turn automatically, it would lift the implement, etc. And that is now working very well. And I would say it's nearly standard now on larger agricultural machines. So when I look into our sales and our orders, let's say starting at 150 horsepower, I think a tractor is ordered with such a system. And so we have sold already hundreds of thousands. We also see a trend towards higher accuracy. So customers want to have RTK. And that now, I think, with having said that this now works so well, so the question is, this is also a prerequisite for a lot of autonomous vehicles to have this high accuracy in the field where you have no trees or nothing which can guide you. So when we look into autonomous vehicles, I think we see in the past this has been mainly done at universities. So here you see also some newer, some older pictures from universities, some research, what has been done. But just recently, that changed also, and we see now large manufacturers looking into that, talking about offering that. And here you see Agritechnica, that was last year in November, and there were quite a few announcements or things shown related to autonomous, and autonomous in that context means really driverless tractor. On an autonomous car, we wouldn't still have somebody in there. Here it would be really driverless. And you see, Case has made some announcements that they will introduce such a tractor without a cab or with a cab. Also, Professor Noguchi has already shown Kubota, they have made announcements around this driverless combine or a tractor or that small rice transplanter. We have seen that our competitor Fendt has shown a small robot called Xaver for planting corn or maize, and which is still, all of that is not commercially available, but has been announced to become commercially available soon. And therefore the question is, what is John Deere doing? And I only want to show you here some videos which are also from the resolution, and you see they are old. So on the top, the left on the top, that's a tractor that we showed 2003 at the Agritechnica already, without a cab, for use also mainly in orchards, for spraying. We had also another here tractor below. On the right-hand side, you see tractors running on our test center, where we do tests, durability tests. And so there are no drivers on these tractors. We just run them 24 hours to see that they are reliable. So in general, I think the technology, like I said, 15 years old, the technology is there. So the question is this the future? Will they be replaced by fully autonomous systems? And you see here, that guy, he doesn't have a remote control. He has a drink. He just is watching. He's not controlling these machines. So I would say I don't have a crystal ball, and I'm not a prophet and can say when that will come. Definitely some will come, some might not come. So I don't expect, or we don't expect at least robots for all areas of agriculture, because we still have challenges to overcome, but we also have drivers who will speed up that. And I want to talk now about drivers and challenges. So one, we heard that already very often. The biggest driver for autonomous vehicles or field robots is probably the shortage and the cost of educated labor. And here we have to distinguish between large arable farming and specialty crops. On large arable farming, wheat or maize, the costs of labor are so minimal. So to take away the driver from a large tractor, that doesn't save a lot of money. That's definitely below 5%. Only the introduction of AutoTrack, our automatic steering, has already improved productivity by around 10%. But it's different in specialty crops because their labor, either we have no machinery at all, it's still manual, and therefore labor is very, very expensive. Or we also have the issue that we don't find labor anymore, so that we don't find people who want to do that job. And we see that last year already in the UK, I heard that 30 or 40% of the strawberries couldn't be harvested because they didn't find people to do the job because the Romanians didn't come anymore because of Brexit. And we hear similar things also in Germany. We have a lot of Eastern Europeans who are coming for vegetable growers, and it's getting more and more difficult. So there, definitely, we need robots first. On large arable farming, we also see that in some really large, in areas like Kazakhstan, where you have a field with 1,000 hectares, and to run a tractor 1 hour this direction and turn and then drive another hour in the other direction, that's so boring that nobody wants to do that anymore. And there probably it could also come on large machines, but mainly in specialty crops. We still could do cost reduction of an unmanned machine. We need no cap, but also this is not so much money we save on a, let's say, 150 horsepower tractor. The cap with all what is in there, air conditioning, etc., is less or around 10% of the total cost. So we couldn't offer the machine so much cheaper. On the other hand, we have to add a lot of sensors and technology, which makes the machine more expensive. Soil compaction, also that was already mentioned, but here you can say with our existing large machinery, we also have options still to reduce soil compaction. We see more and more tracks instead of wheels, which have a very low compaction when you do track on large machines. We can do controlled traffic farming, mainly also a big topic in Australia, where you just use always the same tracks and don't touch the other soil anymore. Or you can do much lighter weight machines or lightweight robots. So there are different ways how to reduce soil compaction. But at the moment, that's definitely a driver. Another driver is we can reduce input costs through precise placement of whatever seeds or fertilizer. We sometimes even talk about single plant treatment, and a single plant treatment would definitely only be doable with a small, really small robot who can touch every single plant, and it's probably more in row crops. But I think we have also, when you look into our company, Blue River Technologies, where we do weed identification too on a traditional tractor implement combination and then spray only the areas with weeds. Also there we can reduce input by 90% probably. Another driver, autonomous cars and trucks. First of all these autonomous cars, they need also a lot of sensors. So the cost reduction for the sensors is tremendous. When you see the safeguarding sensors, what we have paid 5 to 10 years ago, probably now we pay 80% less. Also, the legal approval discussion can help. One challenge is to bring the machine to the field. And on trucks, we talk about platooning, so that you have one truck which is followed by 2 other trucks without a driver, and the other trucks following so close that no company or no passenger car can go in between. So if that would be allowed, that you can run these trucks on public roads, then the same could be true also for large ag machinery. Then we see a lot of educational focus on robotics. Robotics is interesting, a lot of students interested in that. You see a lot of student competitions around that. And we also see, and especially here, a strong focus on venture capital and also startup companies on agricultural robotics, even if probably not venture capital companies got it so far. Unfortunately, John Deere doesn't have a venture capital arm. Otherwise, I would have invested already in field robots. But these are all drivers. So there are a lot of things which will speed up the development here, but there are still a lot of challenges to overcome. One thing is product liability, and especially for a large American company and with the American liability laws, if such a robot would kill a human being, that would be a disaster. It would be a disaster for our image, but it would also be financially a disaster because we would pay hundreds of millions on fines. So therefore, I think our lawyers, they tell us as long as this is not bulletproof and as long as there's no really big demand from the customers, we should stay out of that. Legal situation, driving on public roads, we mentioned that already. That's not allowed yet. Then the safeguarding sensors, which we are using in cars, which are now so cheap, not all of them are usable for us in agriculture because we have dust, we have dirt, fog, vibrations. So this is still, we need other sensors which are still, in some cases, need to be developed. Then we don't drive just from A to B. On a farm, we do a job. We do a job with our machines, and that means we have an implement who does something, or we have a combine who is harvesting, and there are so many things going on where we still see the value of a driver to monitor that. Let's say you have a tractor implement combination, you have a blocked pipe on a seeder, or you have residues piling up on an implement, on a tillage implement. Then, okay, you can put sensors there and can stop the machine, but then somebody has to go there and has to remove that blockage. So if that is somebody who sits in his office half an hour away from the field, then this is a time-consuming event, and we have so short period windows where you can do the right work in the field, so that would be also a challenge. Logistics, also this was mentioned, as long as you do weeding, that's relatively easy when you want to spread fertilizer, when you want to put seed in the ground. This gets more complex because then you need also, or if you collect harvesting material, that is something which needs at least more work and more effort. And we still have that issue of transport to and from the field where we need a trailer or whatever. When we talk about autonomous vehicles, then we definitely need to not just say we take the cab from a tractor and everything is fine. In that case, we need to think about a total redesign of our machines. And you see here just some examples, some sketches, how such a machine could look like, what they could do. And we wouldn't see probably a separate tractor and an implement. This would be more a combination. And then you can think about totally new cropping systems. If you have small robots, why should you have a field with only one crop? You could have stripes of different crops, which could have positive phytosanitary effects. So there are also research, I know at least in Germany at universities, looking into that. And one challenge is also the availability of just engineers, because robotics and artificial intelligence, and that has such a hype at the moment. And I think all engineers or some engineers who would like to do that, they are even not aware that John Deere or that agricultural manufacturers would need these people, and they prefer typically not to go to the Midwest. They want to live in California and want to work for Google or want to work for Uber or whomever, or for a big automotive company, but to attract these people is also still a challenge. So I come to the next point where I want to give you, and I can go very quickly because that has been mentioned in other presentations, what are the right applications for robots or for autonomous vehicles? You see here weeding, and you see some of the machines which you can see out there, or some of the companies which are out there. The other thing is spraying, because spraying is also still a challenge because you have pesticides, you have toxic pesticides, or especially insecticides, which are toxic for human beings. So if you can eliminate the driver and can take him out of that, then it's definitely a value. Here you see here almond spraying, I think in California, or Yacto is from South America, or again, Swarm Farm Robotics from Australia. So spraying is an area. And harvesting, that's definitely a big deal for vegetables or for specialty crops. You see here apple picking, or that is also on top the Harvest CROO robotics machine. That's not a John Deere machine, it's only a John Deere trailer machine, We are not involved in that development, but they're working on a strawberry harvester. And hands-free hectare, I don't have to talk about that because there will be a separate presentation later. So when you talk about then these applications and small field robots, then you automatically say, how can I do larger fields? And then we need to talk about swarms. And so do we see a trend towards swarm technologies? I wouldn't say that we already see a trend, but if the machines are getting smaller, this is the only way to reach some level of productivity. So, and you see here that Fendt Xaver, they also talk about a swarm of whatever trailer with 12 robots to do planting, but then they still can do with the 12 robots 1 hectare per hour, and they need to be refilled and recharged. And so it's very tough to compete with a large seeder and a large tractor. So I think cost-wise, that probably will be very difficult. We are also looking into that. We have at the moment a project funded by the German government, which is called Feldschwarm, Field Swarm. And here we look into, let's say, what could be a swarm of autonomous and semi-autonomous operating implements. So on the left side, you see just a running implement. There's no tractor involved. Then you see a tractor with a cab, without a cab. So in that project, we are looking what is the right size for which application and how that could all work. We think that this will be very much electrically driven units. And with that, we are quite sure that we can reach a much higher automation level with lower specific power requirements. So field swarms is something where John Deere, where we are also looking into it. And we also look into the role of electrification, because a lot of these robots, okay, they are sometimes using batteries. We still have some with diesel engines. But we are convinced that electrification will become more important. And so we do it there. We want to be prepared. And this is, for example, a tractor that we showed on the SEMA farm show here in Paris several years ago, and we got also an innovation medal. The challenge is, this is a tractor full with batteries, no engine, no transmission, and but it runs only 4 hours, let's say on the street, and let's say 1 hour if you do plowing. So the power density is just too small. It's not usable for 24-hour operations on large farms. So what are the options? When you talk automotive, then they say fast exchange of battery packs is one option, could be one option. You could use solar panels for low power applications. We see that on the eco-robotics robot. Fuel cells is something we are looking into it. And one option is connecting the machine to the grid. Because nowadays we see more and more wind turbines. We see a lot of areas where you could easily connect to the grid. And here you see an example from a machine from Russia from the 50s. That was an electric tractor powered with that cable. And we looked into that and said, why not trying that out? So you see here a project at our tech center in Kaiserslautern. You see also a tractor, a pure electrically driven tractor without a cab. It has two 250 kilowatt electric drives, one for the implement, the other one for driving forward. It has that cable which is laid down when you drive up the field, and then when you drive back, it's collected again, and this works perfect. When you put in John Deere and whatever autonomous tractor in the internet, you even find a video where you see how that is laying down the cable and turning, etc. For the sake of time, I didn't want to include that here because I have only 20 minutes, and I think they are now over. So, but when you talk about this, then at least we need to think all alternatives, and that could be an alternative. If you don't have a grid and you say batteries don't last long enough, why not putting then a container with batteries at the field site, and when that is empty after 24 hours, you could replace that by another one. So you still reach at least the long working hours also with other technologies. With that, I want to summarize. I think what we can say is GNSS-based steering solutions, they are mainstream already. We see a growing interest, research and venture capital in fully autonomous unmanned vehicles or field robots, however you call it. We see a lot of drivers towards autonomous vehicles, but we still have a lot of challenges still ahead of us to overcome. And from the John Deere perspective, field robots will be introduced first in specialty crops due to the labor cost and labor shortage. And we also believe that swarm technologies and alternative energy concepts seem to be necessary for introduction in large arable farming. So thank you very much for your attention.
And thank you very much, Thomas Engel.